we want to find the domain of this function h of x, which is defined as the log base 5 of the quantity x plus 1 over x. So you can see that we have a rational argument here, right? We have a rational expression in our argument. And when you're finding the domain of a logarithm with a rational expression in the argument, there's a couple things that have to be considered. First, just like is true for any rational expression, the denominator is not allowed to equal 0. So we have to figure out what makes it 0. And then secondly, we want the argument to be positive, as is true for all logs. And in order to do this, what we're going to do is find the x-intercepts of this rational function. And then we're going to find what makes the denominator 0. And we're going to plot those on a number line and test intervals to figure out whether our graph is going to, or whether the argument would be positive or negative on those intervals, and use that information to find the domain. So let's try this. So again, we know that the denominator here is not allowed to equal 0. And we want to figure out what makes the numerator 0, because that's going to be our x-intercept. So right off the bat, we know that x cannot equal 0. And then from the numerator, we have that x plus 1 equals 0. That's going to give us an x-intercept for the argument. So we get that x equals -1. So these are the two values that we're going to put on the number line, and we're going to test to determine whether our argument will be positive or negative on the intervals that are formed by these parts in our argument. So we have a number line here, and we have -1, and we have 0, and we want to test the values on this interval. So if you pick a value less than -1, maybe -2, and plug it into your argument, we want to know, is that going to be positive or negative? So if x is equal to -2, what happens? So we have -2 plus 1, all of that divided by -2. -2 plus 1, that's -1, over -2, that's going to be a positive 1/2. So this entire interval is going to be positive. Let's pick a value in between -1 and 0, maybe -1/2. So if x is equal to -1/2, what do we get? So -1/2 plus 1 divided by -1/2. This is going to give me positive 1/2. Positive 1/2 divided by -1/2 is going to be -1. It's going to be a negative value. So everything in between -1 and 0 is going to be negative. And then lastly, let's pick a number greater than 0 to test that interval. Maybe we can see what happens when x is equal to 1, and then plug it in. So we get 1 plus 1, all divided by 1. So that's 2 over 1, which is 2, which is a positive value. So those are the positive intervals. So we know that everything in between -1 and 0 is not going to work. And we know that our graph must be positive. It must be positive, which means that at -1 and at 0, our function or our argument is not going to be defined, because -1 makes this equal to 0, which isn't a value that we can use in our domain. And at 0, it makes this undefined. So we have all of these values to the right of 0 and to the left of -1 that are going to be part of our domain. But -1 and 0 are not going to be included. So it's going to be all of this here to the right of 0 and all of this here to the left of -1. So our intervals are going to look like this for our domain. The domain is going to be everything from -infinity up to -1, and then union from 0 to infinity. So this is the domain of this logarithm.